Hello, we're talking still about zeros, linear functions, and multiplicity. Now we're going to talk about a cubic function and a quartic and talk about the general rules that apply. Okay, so remembering that zeros are roots or x-intercepts. Linear factors are something like this, being able to factor a function out into its linear factors. Multiplicity, how many times each linear factor exists or repeats. So let's take a look at this cubic function. F of x equals x cubed, subtract x squared, subtract 2x. All right, so just thinking about leading coefficient, the leading coefficient is positive and the power is 3, highest power is 3. So we know then that this is an odd function with a positive leading coefficient. It's going to be in this sort of a shape, okay? So keeping that in mind, let's factor this guy. So if it's factorable, makes things a lot easier. So we'll let y equals 0, because remember you can always find x-intercepts by letting y equal 0. And then we're going to see if we can factor this side. So there's a common factor there of x, which leaves us x squared subtract x subtract 2, which is a quadratic that we can factor. X subtract 2x plus 1. Okay, so using the null factor now, we can say x could be equal to 0 with that number, or x minus 2 could be equal to 0, or x plus 1 could be equal to 0. And then solving each of these, x equals 2 here, x equals negative 1 here. So now we know that there's 3 x-intercepts. The first one's at 0, 0. The next one's at 2, 0. Oh, and there's one back here at negative 1, 0. Okay, so those are the x-intercepts. Now, let's think about the multiplicity here. Multiplicity tells us if multiplicity is odd, so 1, each of these is multiplicity of 1, okay, only happening once, which means that the graph is going to cross through that x-intercept, cross right through the x-axis, okay? So again, thinking about that shape that we said, okay, like this, that means then that we're going to start down here, we're going to go through, going to turn somewhere up here. I'm not concerned about the turning points right now. We could figure those out with our graphing calculator, but next year you'll learn how to find those in calculus as well. So down here, through that one, also crossing through 0, 0, and then crossing through again. Okay, so looking something like this, at least the shape is there. The relative max and relative min are not drawn to scale, just so you're aware. I don't have a scale on the y-axis here. All right, so let's take a look at the quartic. What's another thing to notice here? We have a power of 3 and there's 3 x-intercepts, and that's as many as we can have. You can only have as many x-intercepts as the highest power. Okay, you can have fewer than that, but you can't have more. All right, now, so g of x equals x to the power of 4, subtract 2x cubed, subtract 8x squared. Again, let's try to find algebraically the zeros here. So set y equal to 0. And again, here we happen to have a common factor again. It's x squared this time, which leaves us with x squared minus 2x subtract 8, which is a quadratic that we can solve, we can factor. X minus 4, x plus 2. All right, so we have here 2 x's. So x could be 0, but the multiplicity of that is 2. X minus 4 could be 0, so x is 4, multiplicity 1, and x plus 2 is 0, so x negative 2, multiplicity 1, okay? So these refer to 0, 0, 4, 0, and negative 2, 0, all right? Multiplicity here is 2. Which means at this x-intercept, we're just going to touch or bounce off the x-axis and not cross through it. Multiplicity 1 here, multiplicity 1 here. So we're going to cross through at both of those places. So let's see what kind of power we have, an even power, and the leading coefficient is positive, which means we're going to start up and end up. Okay, so basically we need to cross through the negative 2, 1, because multiplicity of 1, so we need to cross through there. At 0, we need to only touch, so we need to come back up and just touch, and then we need to cross through over here. Okay, so again, these relative mins are not to scale. We could figure out them based on graphing calculator, but we're not concerned with those as much today. Okay, so we can get the general shape, the behavior of that graph based on the zeros, the linear factors, and the multiplicity of those factors. So let's talk about some rules. If the multiplicity is odd, okay, multiplicity is odd, then the graph crosses the x-axis at the 0. If the multiplicity is even, then the graph only touches. All right, so even, then the graph only touches at that 0. All right, so if you were given a question like this, example, f of x equals x plus 7 to the power of 2 times 2x plus 1 times x subtract 4 to the power of 3. So let's talk about what power of a function this is. There's x and x here, so that's x squared. Another one, x cubed. 3 more would be x to the 6th. So it's an even powered function. The leading coefficient is positive, so we're going to start up and end up. Okay. All right, let's talk about the zeros. If we solve, let y equal 0, then we would have x plus 7 could be 0, which means we have a 0 at negative 7. Okay. It has a multiplicity of 2, which means that it's just going to touch that x-axis. Okay, just touch it. All right, next one, 2x plus 1 could be equal to 0. Well, we could solve that. If you want to see that, 2x plus 1 could be 0, so 2x equals negative 1, x equals negative 1/2. Okay, so negative 1/2, 0 is another x-intercept, and the multiplicity of that is only 1, which means we're going to cross the x-axis. Okay, and the last one, x minus 4 could be 0, which means we have this x-intercept 4, 0, and the multiplicity on that is 3, which is odd as well, which means it also crosses at that point. So you could figure that out. You could figure out the general shape of this graph based on the multiplicity, the zeros, the effect that it has, as well as the leading coefficient and the power of that function. There we have it.